During the bounded area highlighted in red. Okay, let's do this one with columns. So we'll put a column here just as a representation, but this column can go along here anywhere we want. It's going to have width of dx, and the height is going to be called just height for now. So the area of this little column is going to be dA, and it's equal to the height times dx. But we don't want dA, we want all of A. Okay, so we want to integrate this. So we're going to add them all up. All these little columns, we'll add them all up. The integral of 1 dA is going to be equal to A, which is what we want. And now this one, we have to integrate this thing in terms of x, dx. So where are we going to go? We don't want the area over here. We don't want the area over here. We just want to have it from 0 to 2. So those are our limits of integration, from 0 to 2 in terms of x. Everything has to be in terms of x here because that's what we're doing. It's making little columns with width dx. So even height has to be in terms of x. So how are we going to get the height here in terms of x? So given an x value, how do I determine my height? How do I make a? Oh, well, y, because y is the vertical distance, right? So if I give x equals 0, it would be negative 1 squared, 1 minus 1 plus 1 is 0. Yeah, exactly, right? And if I give a 2 in here, 2 minus 1 is 1 squared, negative 1 is negative 1 plus 1 is 2. Yeah, it's 0, right? So this is the height function. So here, h is equal to negative x minus 1 squared plus 1. Okay, perfect. And it's in terms of x. That's exactly what I wanted. So integral from 0 to 2 of negative x minus 1 squared plus 1 dx. Okay, so now everything's in terms of x, and now we can integrate this guy. So I could expand this. It would probably make my integral a lot easier. But hey, let's just do some substitution, okay? So because I see that the outside of this will be, is going to be, has a derivative of the inside, where x is going to be, derivative of x is going to be 1, and I see the outside is going to have that. So let's do a substitution rule. So u is equal to x minus 1, so therefore du by dx is equal to 1, and dx is equal to du. Okay? So let's do that substitution. I don't need to do substitution on the last one because I can take the integrate with 1. I'm just going to do the integral. I'm just going to do the substitution here. So I'm going to break up the integral. So it's going to be integral from 0. No, it's not. The units change when you do a substitution, because now I'm talking about terms of u. So this is going to be minus u squared dx, which is going to be du. Plus the integral, this one's still going to be in terms of x, of 0 to 2 of 1 dx, okay? So that one's still good. I'm going to separate it right here. But this first one, the limits change. It's a little hard to understand, but because I'm now having an integral with respect to u, I have to change the limits as well. So I have to put these values into what I've considered u, right? So 0 minus 1 is negative 1, so this one goes to negative 1. And then 2 minus 1 is 1, so u is equal to 1. Okay, so there's the new limits in terms of u. I'll probably switch back in terms of x anyways, but we'll talk about those later on. Let's follow this integral. So this is going to be negative 1 over 3 u cubed with integrals of negative 1 to 1, plus this one's just going to be x with from 0 to 2. Okay? So you can see if I switch back, this might be a little confusing here, but if I switch back, so 1/3 u is equal to x minus 1. Now we're back in terms of x, and now I can add this guy here, and I can put one limit here, which will be from 0 to 2. So I want to show you here. I think this will all be made clear once I plug these values in. So let's do the actual bounds now. So it'll be equal to negative 1/3 2 minus 1 cubed plus 2, okay, minus negative 1/3 0 minus 1 3 plus 0. Okay, so I just put my x values in where x's were, right? And you can see that it is exactly the same as this 2 minus 1 will equal negative 1, and that is what this guy was, the lower bound, right? Oh, maybe I did that wrong, because you're right. 0, if I put 0 in, 0 would be negative 1. Oh, no, so... Oh, 2 minus 1, I'm sorry. 2 minus 1 is 1. Okay, so that's the upper bound. 2 minus 1 is 1, and that is the upper bound. and then 0 minus 1 is the negative 1, and that was the lower bound. Okay, so that's what I was talking about, switching the bounds if you do a substitution, okay? But we switched it back into the x domain so we could use our original x limits, okay? So regardless, here's our answer. Let's plug all these values in. So we're going to have negative 1/3. This is going to be 2 minus 1 is 1, okay? Plus 2 minus, this is going to be negative 1. So it's going to actually be plus 1/3. And then plus 0. Okay, so what do we get here? We get negative 1/3 minus negative 1/3. So that's going to be equal to negative 2/3. So it's going to be 2 minus 2/3. It's 3, so it's going to be 4/3. I'm going to go with 4/3. Yeah, because this is 2 is equal to 6/3 minus 2/3. Yeah, it's 4/3. Okay, so it's equal to 4 divided by 3. And in decimal form, that would be equal to, I think it's 1.3. Yeah, 1.3 repeating. And there is your answer.